Hello, let's do the New York Times Hard Sudoku for June 1st, 2026. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, starting in this top left box, we do have two fours looking in here. Putting a 4 in one of these two. All right, I don't see anything else with that 4. Let's move on. Here we have a 4. I think these are the only two 4s. Yeah, okay. The 5. Okay, this 5 looks in, this 5 looks up. So 5's in one of these two. Ooh, I completely missed this 5. These two 5s look in, this 5 looks in. That places the 5 very conveniently on top of where we thought a 4 could go. So now the 4 goes there. We are down to 3 digits in this box. What are they? The 1, 3, and 8. So we know this one's not 8. That's it. Oh, that one's not 1. Missing things. All right, that's not 8. So the 8 goes in one of these two. That's going to point. This 8 looks in, putting an 8 in one of these 3. So we learned these two aren't 8. All right. These two 8s do look down. This 8 looks in. Placing this 8. These two 8s look in, putting an 8 in one of these two. Okay. 4, 5, 8. Sorry, I'm looking at this 1, 3 against this column, but it's not quite there. All right. Anything else with this 4, 5, 8, though? It feels like there should be something going on here, but I guess we'll get to it. Let's look at this box here. Let's just look at what looks into it. The 5s are done, the 7s are not. These 7s look down, this 7 looks in. Placing that 7, these 7s look in, this 7 looks down, putting a 7 in one of these two. All right. That was 7 and 5. How about 1, 6, or 8? So the two 6s look in, putting a 6 in one of these two. And then the 1 and the 8 aren't placed up here yet. Okay. I think that's it for this top band for now. Let's move on. We have 1, 7, and 9. These two 1s look in. This 1 looks in as well. Placing the 1, which then also places the 6. And the 1 looking up places the 1 in this box. We now have a 3, 8 pair. So these aren't 3 now. I mean, these 3s look up, but no, there's nothing to do with that. How about this 1 that we placed? Nope, not that either. 4 digits left in this row. Let's take a look at that. We need a 1, 2, 6, 7. This is 2, 6, 7. This is 1, 2, 7, because it's not 6. And this can't be 1 or 7, so this is 2, 6. All right, nothing from that yet. All right, let's, what were we on these? The 1, 7, and 9? I think we just did the 1. Now this is a filled box column. Actually, we should look at this whole stack because we have 3 digits left here, 3 digits left here. Let's look here first. We need a 2, 3, 4. This bottom one's not 3, which is important because it means 3 is in one of these two. So we've eliminated 3 now from these cells because if 3 is in one of these two, it can't also be over here. These 3 digits, I should say, are 3, 8, 9. Well, these two can't be 8, so it places the 8 in the column. That gives us the 3. And then this is, I don't remember. This is 6, 9. Oh, no, not 6. 1, 2, it's 3, 9. All right, and then this is 2, 4 then, because we have 3, 9 pair, that leaves a 2, 4 pair. And so what are these digits? The column needs 2, 4, 8, 9. So unfortunately, this is all of 2, 2, 4, 8, 9. But this is 2, 4, 9, and this is 2, 4, 8. Now we do know that the 8 is in one of these two, and the 9's in one of these two. All right. That was, okay, let's just keep following. Let's just keep doing scanning now. So these 7s look in. 7 in one of these two. And then the 9. 9 is not helpful. This 1, 3, and 8. I'm still noticing 1 and 3 need to be here. It's no good though. All right, anything else with 1 or 3? Or the 8? 8 looking in doesn't do enough. No, I don't think so. Does anything cross here? So 4 and 6 look in here. Oh, the 6 crosses. This 6 looks in, this 6 looks in. Puts a 6 in one of these two. That points in here with this 6. Puts a 6 in one of these two. In fact, this row's just down to 2, 4, 6, 9. Let's look at that. So this can't be 4 or 6. This is 2, 9. These can't be 9s. These are 2, 4, 6. Right. Okay, so that's why we saw the 6s there. Any other crossings? The 4 does not. I do notice 4 is down to these 3. I also notice this cell is not quite a few. This can't be quite a few digits. Because it's not the 1, 3, 8, but it's also not the 4 or the 6 or the 7. So it's down to 2. See, not 3, 4. It could be 5. And I believe it could be 9. So 2, 5, 9. Nothing immediate from that. Okay. Any crossings this way? No. It would only be the 7. Anything else in this band at all? Not yet. All right, let's move on to the next band. So the 3 doesn't do anything. We have 6, 7, and 8. So the 7s and 8s are already marked. The 6 is not. So 6 is one of these 3. I think that's all we get. All right, clearly we're not done. I'm going to scan rows for anything that might be worth marking. I'm going to do just a really quick initial scan to make sure I didn't miss anything obvious. Then I'm going to do the columns. Make sure I didn't miss anything obvious in the columns. And then we'll go to some slightly less restricted cells. So this is still down to 2, 4, 8, 9, I believe. Yeah. All right, so we're going to do rows with 5 or more left, like this one. Basically, if this got 4 givens or more. So we need a 1, 2, 3. I missed something. 1, 2, 3, 6, 9. 1, 2, 3, 6, 9. So we're looking for any cell that sees 2 of those digits. So like this sees 1, this sees 3, this sees 9, but nothing sees nothing sees 2 or more of 1, 2, 3, 6, 9. This sees 6. All right. How about this row? We need a 3, 5, 7, 8, 9. This can't be 7, 8, or 3. So this is 5. Oh, wait. It can't be 5 either? Hold on. Well, first of all, these can't be 5. Yeah, I missed following up on that 5, I guess. 5's in one of these 3. But what are these down to? Because they're not 5, 8. So 1, 2, we need 3, 7, 9. And this can't be 3, 7. So this is a naked 9. And this is down to 3, 7. This can't be 3, 7. So it's only 5, 8. All right. So I place this 9. These 9s look in. Placing the, or not placing, but putting the 9 in one of these two. 3, 7. 5 and 8 are over here. Yeah. Did I miss anything else looking into this box? It doesn't look like it. Okay. I want to look at this whole box though. We need, it's 5 digits left. We need a 1, 2, 3, 6, 7. No, I don't think we get more out of that. It was this row, and we already looked at it. All right. How about this column now? It's down to 4. Because we placed that 9. We need a 2, 4, 5, 6. We know these aren't 6. These are 2, 4, 5. Top one's not even 5. That makes a 2, 4 pair in this top row. The best time to find a pair is when you penciled. So I penciled this 2, 4, and I immediately scanned its vicinity for another 2, 4. And I found it here. So we have that pair. And that means there's only 3 digits left in this row. We need a 1, 8, 9. 1, 8, 9. So this is 1, 9 only. This is 8, 9 only. And this is 1, 8 only. Okay. What was this? 2, 4, 5, 6? I think it could be any of them. Interesting. I'm noticing this 5 looking down, this 5 looking in, putting a 5, one of these two. I'm trying to see if anything else is restricted here. Is there any digit we haven't mentioned here? 1, 2, no. 3. the 3. So 3's in one of these 3. Doesn't really help. 4, 5, 6, 7, 8, 9. No, the rest are mentioned. Okay, let's move on, I guess. Let's keep looking at rows. There isn't another row that looks tasty. Let's look at columns. No columns either. All right, how about boxes? Is any of this pointing or claiming, or is it all just markings? That's the question. 3, 8. The 6 and the 7. What I'm doing is I'm making sure that the corner marks that I have are actually getting respected, because sometimes I'll pencil and I'll not notice a corner mark. The 3s, the 8s, and the 9s, it's all respected. The 8s here, yeah, it's fine. 6s and 7s. Okay, there really isn't anywhere obvious to look here. Makes me think I missed some geometry. There's nothing looking through here. I'm looking for crossings. 2 givens that share a row or column, like these 2 share a column in the same box. We want to look at what might go through that. So the 3, for example, unfortunately, we don't have any help on 3s. The 4 does it too. Ooh. The 4 is already placed in the box. Never mind. All right, not there. We already looked here. We did this already. It would just be here. This is already penciled. 3, 9, and 2, 4. All right. Well, maybe it has to do with the fact that these aren't 2, 4, because we did find that 2, 4 pair. So removing 2 and 4 from these, does that do anything? I just don't see how it helps. All right, so what else did I miss? 1, 2, 6, 7. We already know those aren't worth penciling. Maybe I should pay attention to this box. I mean, it's a lot of digits left. It's 6 digits left, but the 9 looks in here. Maybe I should look at these 2 digits. So 1, they could be 2. I'm going to mark it out, but I might delete it if it's too many. We need a 2, not 3. The 4 could go here, but not here. The 5 can go here, but not here. The 6 can go here. Oh, actually, neither can be 6. We need a 7. Both can be 7, 8, 9. So they are down to 2, 5, 7, 2, 4, 7. What digit haven't we accounted for here? It looks like it's the 3. So 3 is here or here. I don't think that helps. Okay. So what am I missing? Look for more restricted cells, I guess. These can't be 3 or 4. They're not 1, 7, 9. They're not 3, 4. This one's also not 6. So it's not 1. It could be 2. It's not 3. It could be 4. Oh, it can't be 4. It could be 5. Not 6, 7. It could be 8. So 2, 5, 8. So we don't have a whole lot penciled in this column, but one question we might be asking is, do we have a 2, 5, 8 naked triple? If you're curious, without having to pencil the whole column, what you can do is you can think about what are the 3 remaining digits besides the 3 givens we have and 2, 5, 8. So those remaining digits are the 1, 6, 9, 1, 6, 9. So if there's any cells here that can't be all of 1, 6, 9, then we're good to go. That would be a 2, 5, 8. I'm not seeing that, but I am seeing this cell can't be 1, 6, and this cell can't be 1, 9. Oh, it can't be. Actually, no, this cell can't be 1, 6, 9 because we have the 6 is cornered. So we actually found it. Okay. So this is down to 2, 5, 8. So let's just double check. It's not 1. It could be 2. It's not 3 or 4. It could be 5. It's not 6. We have the 6 is cornered and pointing. not 7. Could be 8, and it's not 9 because there's a 9 in the box. And so that is a 258 triple, leaving behind 169. We know this one's not 16, so that's a naked 9. And before I follow up on that, I'm going to write 16 as the remaining digits here. So it does place the 9 in this box, which gives us the 8, 1, and 9 here. The 9 also looks over, giving us the 3, 9 here. And the 1 in this box tells us that's 6, and that's 1. All right, so that is what we needed to spot. I didn't actually think we'd find that, but that's why we look, right? So the 1 in this box is placed here. The 2 ones look down, 1 looks in, placing the 1 here. 1s are now done. The 4 digits left in this box are 2, 4, 5, 7. We know these aren't 7, so these are 2, 4, 5. Surprisingly, these are any of 2, 4, 5, 7. I feel like we're slowly collapsing. Maybe I should look at better low-hanging fruit. This is 2, 6, 7. So we know that the 7's in one of these two. These 3 are 2, 3, 6. I'm only seeing this 6 here. Okay, 2, 3, 6. So the 7 can only go here in this box. That gives us the 7 in this box. That's another 2, 4. We have so many 2, 4s. I'm trying to figure out where I want to look next. We just got a bunch of digits. The 6, the 9. Maybe this box? So 2, 3, 4, 5. Yeah, the 3's in one of... Oh, the 3's placed. That's even better. 3 looks in. This 3 looks in. Place the 3, which then places the 5. This is down to 2, 4. Oopsie. Down to 2, 4. That 2, 4 pair says that's not a 2. This is the 2. That's 9 and 5. That's 6 and 3. That's 6. Places the 6 here and the 6 here. The 9 gets placed. It can't be here anymore. So that's 9, which makes that 8. Do I clean up, or this is 2, 4? We have so many 2, 4s that need to get resolved. I'd rather not clean up, but I guess I will. All right. Isn't that a perpetual state of being? I don't want to clean up, but I guess I will. 5, 8, and something else. 3. All right. Where am I looking? Look at all these 2, 4s are crazy. I bet you we could find a well, I don't know if we could, but it seems likely we could find a remote pair. So just to demonstrate that what I mean by that, because it's a fun technique, a remote pair. So I'm not going to use it, but we'll see if there is one here before we accidentally finish the puzzle, before I get to explain it. So I'm going to call this cell green. Whatever digit the solution ends up being, I'm going to call that green. So we know green is a 2 or a 4. Now, let's just pick this one here. This cannot be green because it's in the same column as green, but it's also a 2 or a 4. We're going to call that purple. So if green is 2, purple is 4. If green is 4, purple is 2. That's the point. And so we can actually propagate it kind of like a virus. This pair says this has to be green. This pair says this has to be purple. That makes this one green. That makes this one purple. And this one's purple. And this one's green. So what we'd be looking for is, for example, right here. This would be useful if we were going to use it. I'll leave these colored, by the way. But this cell here, you'll note that it cannot be purple because it shares a column with purple, and it cannot be green because it shares a row with green. So you can kind of think about that this one of these is 2, one of these is 4. You can think about it as this seeing a 2, 4 pair. And so it can't be a 2 or 4, so it's going to be a 5 or a 7. And it actually can't be 5. We should have marked that. So actually, if we have these marked as 2, 4, 7, that makes it even more powerful. We'd be able to place the 7 here because we know it's not 2, we know it's not 4, because I don't know which is which, but we know it's not either of them. So that would be a way to progress this puzzle, but certainly not the intended way by whatever algorithm constructed it. The 8's in one of these two. I feel like I just kind of have to pencil these and find out what's going on. So why don't we just think about this row, 2, 3, 4, 5. I mean, it can be any of those, right? How about this row? 2, 3, 4, 8. I just don't think these are the key. I must be missing something simpler. The 5s, the 7s. 2, 5, 2, 8. Do any of these pairs actually just affect their row or column or box? No. So what's the real step? It should just be pointing, claiming, pair, triple, something like that. Maybe there's a hidden single I haven't noticed. Since we're at the end of the puzzle, I'm just going to mark these up, even though they're more than 3, because I'm just not seeing it. This is 2, 3, 4, 5. Oops, 2, 3, 4, 5. And this one is 2, 3, 4, 8. 8's one of these two. 7, 2. It's a hidden 3, 8 pair here. That's what I'm missing. None of these can be 3 or 8. Let's find out why. So we have a 3, 8 here. We have the 3, 8 here given. And we have the 3, 8 here. So where do 3 and 8 go in the column? They go right here. And so this can't be 2, 4, and this can't be 5. Now, we remove 2, 4, 5, 7-ish from these. Not 7s, 2, 4, 5. What do we do with that? You'll note that this one also saw a remote 2, 4 pair, by the way. I hadn't noticed that till just now. So did this not do it? We removed 5 from here. So what happened is, oops, sorry. What happened is 5 in this column is now only here because we removed it from these two. This is the last one for 5 in the column. I noticed that by having these, I was like, we removed 5 from here. Now 5's in these two. And I noticed in this box 5's in these two. And so as a result, we need a 5 in this column, which goes there. All right. And so now this is a green 2, 4. So now we would be able to eliminate 2, 4 from here because it sees this green and this purple and this purple. But it sees a green and a purple, so this isn't 2, 4 either. Just remote pairs are neat. When you have a ton of the same buy value in the grid, it doesn't hurt to color them if you're stuck. Are we really not done yet? I got this 5. Okay, I'm going to mark that 5s are here and here. What did that do? This is down to 2, 4, 7. Oh, we have a 2, 4, 7 triple here. So yeah, this is a hidden 3, 5 pair is another way to put that. So that makes it not 2, 4 as I was talking about. So not 2, 4. That leaves 4 in this box. 4 can only be here. And so we know that all of our purples are going to end up 4 and all of our greens are going to end up 2. We can get rid of the colors. And that should finish the whole thing. So that's 8, that's 3, that's 5, that's 2. We get the 5, 3, and 8. We get the 7 and 2. That's 4 and 7. That's 3 and 4. And we're done. Wow. Some tricky steps at the end there. So like just compiling on or compounding hidden pairs, the hidden 3, 8 and the hidden, what was it? Was it this 3, 5, I think? Pretty nasty spots, to be honest. All right. Well, how'd you do?